Hello everyone, my name is Pranav Khandelwal and I'm a postdoctoral researcher in the group. This is my 2023 year in review, which showcases our goal to develop non-invasive tools to quantify animal behavior in the wild. Let me first start by describing why tracking animal behavior in the wild is important. Quantifying how animals move and interact in their natural habitat is extremely relevant to the fields of animal behavior, conservation, and policy making. These fields are not mutually exclusive and address diverse objectives ranging from testing hypotheses to understanding the anthropogenic impacts on animals. Addressing these objectives reliably requires tracking individual and group behavior of animals in the wild. At present, most tracking approaches involve human observers following the animal and recording their behavior. Such an approach cannot be scaled and limits the number of individuals in a group that can be tracked. An alternative approach is the use of biologging devices which are mounted on the animal. However, this approach requires physical interaction with the animal and lacks the environmental context which is essential to understand the factors influencing animal behavior. Our research objective is to address these issues and develop an open source, easy to use framework that can track all individuals, classify their behavior, and record their spatial movement in the wild. We developed a framework using drone videos of a wild population of grevy's and plain zebras recorded at the Impala Research Center in Kenya. In the first half of 2023, we accomplished the aim of tracking individuals and classifying their behavior in the wild. We did this by expanding the capabilities of Smarter Label Me, which is a machine learning assisted annotation tool developed in our group. The schematic on the left shows the entire workflow that allows the user to rapidly generate annotations of each individual in the video and also classify its behavior. This improved capability of Smarter Label Me allowed us to take large volumes of behavior-dense videos and convert them into analysis-ready data. Briefly, the workflow involves three parallel streams. In the first stream, the user starts with pixel-exact annotations of the animal of interest, which will be used to train the animal detector. In the second stream, the animal detector is used to train individuals, followed by manual assignment of behaviors to each. This step is usually fast since the tool automatically generates bounding boxes for all animals in the frame. Using the annotated behavior, the user can now train a lightweight behavior classifier. Finally, using the trained detector and the behavior classifier, the user can rapidly annotate new videos and add that to the training data set to further improve the accuracy of the tool. The annotation output can also be used directly for data analysis or downstream machine learning tasks. Here you can see the tool in action. By clicking Auto Annotate in the top panel, the tool detects all animals and their behavior. The user can now move frame by frame to semi-automatically track all individuals and classify their behavior, and in doing so, correct any errors. We have provided a preprint of this work on bioRxiv and have freely provided over 4,000 pixel-exact annotations of zebras and over 150,000 annotations of zebra behavior, which includes the behavior of grazing, standing, walking, and running. One of the major breakthroughs of this work was that data generated could directly be used to gain biological insight at a much granular and long-term scale. For example, as shown on the right, the per-frame animal tracking and behavior classification can be used to identify behavior transitions and the duration of each behavior, providing a unique look at the activity budget of each individual. In the second half of 2023, we worked towards a second aim of generating the real-world spatial motion of each individual in their natural habitat. We did this by combining the Smarter Label Me output with the telemetry from the drone following the group as illustrated here. This approach allowed us to generate a one-of-a-kind data set that provided unprecedented detail into how animals move and interact in their natural habitat over large spatiotemporal scales. Here is a visualization of the output from our framework. In the drone feed, the number on each box is a unique animal ID and the box color corresponds to the classified behavior. The satellite plot provides insights into the habitat used by the animal group. The bottom right net view shows the close-up spatial distribution of the group, with the drone denoted by the black square. And finally, we have the behavior distribution within the group and the tracked behavior over time for each individual. To summarize, I hope I have provided an exciting insight into some of the research taking place in our group and how we are moving closer towards automatically tracking animal behavior in the wild. The research outcome of this year was a combined effort of all the members of the Flight Robotics and Perception Group. We would especially like to thank Professor Daniel Rubenstein from Princeton University for taking out the time to help us with this research project. Thank you for watching this year in review, and please feel free to reach out to Professor Amir Ahmed or me for any questions regarding this.